Okay, we're on page 3 of Module 3, Lesson 3. So let's finish up today's lesson. So as the last video ended, we were talking about making CD 4 copies of 1/7. So I have that written down here, 1 copy, 2 copies, 3 copies, 4 copies. So whatever number's there, that goes on the end of the number line. So we have 4 copies of 1/7. They want us to describe how can you determine a length of 1. Well, think about sevenths. What is equal to 1 when you use sevenths? 7 sevenths, right? So we have 4 sevenths, so we could add on 1/7, 2 sevenths, so there's 5 sevenths, 6 sevenths. That would make 5 sevenths, 6 sevenths, 7 sevenths. So now we have a length of 1. So we need to describe in words what we did. So we took CD and we added on 3 copies of 1/7 in order to make a segment of length 1. So describe, so add 3 copies of 1/7 onto segment CD. So in order to make a segment of length 1, we have 4 sevenths. We add on 3 more copies of 1/7 to get 7 sevenths, which is 1. So now they're asking us in the next one, what if we wanted to draw a length of 8 sevenths? So use segment CD, it says, to draw a new segment with length of 8 sevenths. So let's try to get this as close to CD as possible. So just follow down. So here's CD. And so we have cut it in half, cut it in half. So we have 1/7, 2 sevenths, 3 sevenths. Here's our 4 sevenths. Now we want to make 8 sevenths. So instead of adding 3 copies of 1/7, we need to add 4 copies of 1/7. So same thing as the one above. So there's 1 copy, 2 copies, 3 copies, 4 copies. So this would be 8 sevenths. 5 sevenths, 6 sevenths. Here's our 1, 7 sevenths, and then 8 sevenths. So we would just say add 4 copies of 1/7 onto segment CD, because it does say describe, so we just said it in words. And you could even show that 4 sevenths plus 4 sevenths equals 8 sevenths, just to show what you did, what your reasoning was. So let's put a little colon there and draw that up there. Okay. Okie dokie. So let's go ahead and move on to number 4. These last 3 kind of make you think. They're a little bit tricky, but I really like to give these 3 as a group exercise and let the groups figure it out, and they come up with some really great ideas. But Unfortunately, we don't have that luxury. So let's read what it says. We have a tower made up of 1-inch cubes. So imagine sugar cubes. And we're making a tower. 12 cubes. So let's go ahead and draw our 12 cubes. So 1, and you'll see on all 3 of these and on several on the test, you can get the answer just by drawing a picture. And they tell you that in the directions on the test, that show work or a picture for your work. So these 3 you'll see pictures, and then the answer practically falls in your lap. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. Boy, my 1-inch cubes are getting bigger as I go, aren't they? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. One more. Okay, now let's see what it says. It says 12 cubes will be 2/3 of the tower. So this is 2/3. And remember that 2/3 means, and this is why we had it on your last test and why we have it on your next test, 2/3 means 2 copies of 1/3. So how big would each copy be? How many squares if this is 2 copies? So we need to figure out how many. So if there's 12 and there's 2 copies, if we cut it in half, wouldn't each copy have 6 squares? 1, 2, 3, 4, 5, 6. So this is half of that. So it's 6. And does everybody agree it's 1/3? Because this is 2 copies of 1/3. So that's 1/3. And this over here would also be 1/3. So we can see our 2 copies. Well, our tower is going to be the whole. So how many do we need to add on to make a whole? We have 2/3. Don't we need 1/3 more? Because 2/3 plus 1/3 is 3/3. So how many more sugar cubes do we need to add on? 6, right? 1/3 plus 1/3 plus 1/3. So 1, 2, 3, 4, 5, 6. So there's another 1/3. So 1/3 plus 1/3 plus 1/3 is 3/3, which would be the whole. So this whole thing is our tower. And they're saying how many cubes will be in our tower? Well, 6 plus 6 plus 6. So our whole tower will be 18 cubes. So the copies language is what got us through that. We said, okay, 2/3 is 2 copies. So I needed to break this into 2 equal pieces, 6 and 6. So to make a full tower, we need 3/3. 3/3 is a full tower, so that's why we added on 6 more cubes. And the total, 18. So see, that one wasn't so bad. Once you draw the picture, it kind of makes sense. This one, a lot of students are like, what? So Jill got 3/4 of a full bar of chocolate. So let's make this bar of chocolate. She got 3/4. So does everybody agree? We look at the denominator and that tells us to break it into 4 pieces. And it says Jill got 3/4 of it. So this is the whole bar. And this is how much Jill got. Okay. And does everybody agree each of these pieces is 1/4? So that's 1/4, 1/4. So Jill got 3/4, and then there's 1/4 left. Okay, so we got that first part. Now it says James was supposed to get 1/4 of the full bar, but he has to get his share from Jill. So here's Jill's. Just look at this piece. This is Jill. He gets 1/4 of the original bar. So does everybody agree James would be right here? Let's give him this piece. So James gets 1/4 of the original bar. So far so good? Okay, now it says what fraction of Jill's chocolate should James get? So this is where you have to think. So James got 1/4 of the whole bar. So let's write that down. James got 1/4 of the whole bar. Which is, what part of Jill's did he get? So here's Jill. Her candy bar consists of 3 pieces, so he got what part of Jill's bar? 1 out of 3. So he got 1/4 of the whole bar, but he got 1/3 of Jill's chocolate. So this shows you how things change depending on what's the whole. If the whole bar is the whole, James got 1/4. But if Jill's bar is the whole, because it says what fraction of Jill's bar, then he got 1/3. So he got 1/4 of the whole bar, but he got 1/3 of Jill's chocolate. I love that problem. Love it. And there's one like that on the test. I just think it's really neat because his fractions change depending on what you call the whole. If you call this the whole, he got 1/4. If you call this the whole, he got 1/3. Okay, let's go on this last one. We have about 2 minutes before the video runs out. So let's try to get through this one quickly. So suppose you have 2½ oranges. There's a nice visual for you. Here's the important part of this problem. A serving consists of 3/4 of an orange. So a whole orange is not a serving, 3/4. So that tells me right away, divide everything into fourths. Because remember, we use the denominator to tell us. So here's 4 pieces for that orange. Here's 4 pieces for that orange. This orange is just a half an orange, so we just draw one line. So 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, 1/4, and so on. So I've done this problem before, so I know the tricky way. If you want to turn off the camera and try and do it on your own first, that's great. But I'm just going to show you a way to think about it using the picture. So 3/4 of an orange is a serving. So does everybody agree that's the first serving? Because 3/4 of an orange. Then this is the second serving, 3/4 of an orange. Then this is the third serving. So 3/4. There's a second serving. There's a third serving. So you got 3 full servings. But this is the part where most students mess up. They go, well, that is 1/4. No, because each serving consists of 3 pieces. So it would be 3 and